All right, we're going to look at a review and preview problem starting with 6.4. Use the diagram at the right to answer the following questions. So before we answer the questions, let's just orient ourselves in this diagram. It looks like we have two lines here, right? And they don't look like they're necessarily parallel, and they don't tell us that they're parallel. And we have a line that crosses them right here. And we're going to call that line the transversal, right? So the first question says, what type of angle pair is Z and T? Okay, so here's Z and here's T. They are interior to our two lines, and they are on alternate sides of our transversal. So those two angles are alternate interior angles. And what is their geometric relationship? Well, if we knew that the two lines were parallel, we'd know that alternate interior angles are congruent. But in this case, we don't know. We don't know what their geometric relationship is. Okay, what kind of angle pair, do S and V form? Okay, so here's S and here's V. They are across from each other at that intersection of the two lines. They are vertical angles. And remember, vertical angles are always congruent to each other, whether or not the lines are parallel. Okay. Last question, name all the pairs of corresponding angles in the diagram. Okay, remember corresponding angles are if I dragged you down the transversal, what angle would be in the same relative position? So Z and U are corresponding to each other. How about S? If I dragged S down the transversal, it would be in the same relative position as X. If I dragged V down, it would be in the same relative position as W, and T would be in the same relative position as Y. Okay, let's look at problem 6.5. Examine the triangles at right. Are the triangles similar? If so, use a flowchart to show how you know. If not, explain how you know. Okay, so let's just notice some things. These two sides, AC and DF, have the same measure. AB and DE have the same measure. And the measure of angle A and the measure of angle D are the same. Okay, so remember for similarity, we have angle, angle, side, or side, side. It looks like side, angle, side is going to work here. So let's make our flow chart. For side, angle, side, we're going to have 3 bubbles. And let's see, the ratio of AC to DF is 9/9, which is 1. And looking at the other side ratio, AB over DE is 13/13, which is 1. And then here we can say the measure of angle A is equal to the measure of angle D. And we can make our conclusion. Remember, we add our arrows. And we're going to use side, angle, side similarity. And we can say triangle ABC is similar to, remember we don't put equals, it's similar to triangle DEF. So there's our flow chart. Part B asks, are they congruent? Okay, remember, if two things are congruent, the ratio between the sides is 1, and that is the case here. So yes, they are congruent because the side ratio is 1. All right, let's look at problem 6.6. Use the diagram at right, write an equation to find x, check your answer. All right, so together we can see that these two angles make a straight line. These two angles are supplementary. If we add them together, they're going to equal 180 degrees. So that's going to be reflected in the equation that we write. If we add the two angles together, they equal 180 degrees. So now we just have a linear equation we need to solve. 3x plus 53 equals 180. We'll subtract 53. 3x equals 127. We'll divide by 3 on both sides. X equals 127 divided by 3, which is some decimal number. All right, problem 6-7. For each of the triangles below, find x. Okay, so let's look at part A. I notice both of these angles are 60 degrees. So what do I know about this third angle using the triangle sum theorem? This is also 60 degrees. And what do we call a triangle where all of the angles are equal? It is an equilateral triangle, and we know that all the sides are going to be equal. So we know that x equals 8 centimeters without having to really write any equations. All right, B. Let's see, what do we have? We have an angle, and we have a side, and we're finding this side here. Okay, so which tools can we use? We're going, the 29 isn't, this isn't a special triangle. We're going to have to use a trig ratio here. So here's our angle. This is x is opposite. 27 is adjacent to that angle. So opposite and adjacent, we're going to use tangent. We're going to say tangent of 29 equals 27 over x. So now we open our calculators and type in tangent of 29. Tangent of 29. We get 0.554. We put this over 1 and cross multiply. 0.554 times x equals 27. I undo the multiplication by dividing. And I get that x equals 48.7, which seems big. Oh, look what I did. This is an easy mistake to make. Good learning opportunity. Opposite, tangent is opposite over adjacent. Did I do that? I did not. I made a mistake. Look at me. Okay, so this is wrong. Tangent of 29 equals opposite over adjacent. So it equals x over 27. So I'm going to cross this out. I'm going to cross that out. I'm going to cross multiply 0.554 times 27 equals x. So I get that x equals 14.97. Okay, I'm feeling a lot better about that. How did I know that I made a mistake there? And it was an honest mistake. This angle is pretty small. 29 is pretty small. I expected this, because it's less than 45, to be less than 27. So when it was greater, I knew I had made a mistake. All right, let's look at C. We have two side lengths. We're finding the third. It's a right triangle. We're going to use the Pythagorean theorem here. 16 is my hypotenuse, so it goes by itself. X squared plus 5 squared equals 16 squared. Okay, x squared plus 25 equals, let's see, 16 times 16 is 256. I'll subtract 25. X squared equals 231. So x equals the square root of 231, which is 15.2. And yeah, I believe that. That makes sense in this problem. All right, Last problem we're going to look at is 6-9. Assume that 25% of the student body at your school is male and 40% of the students walk to school. If the events are independent and a student from the school is selected at random, find the following probabilities. Okay, I'm going to make an area model here. And because we have two different events, right? One is that a student is male or female, and the other is that they walk or let's say just ride a bus or car or something. Okay, and the probability that they're male is 25 and female is the rest. So the probability that they're female is going to be 75. 40% walks, I'm going to write 0.40, and the rest ride. Okay, so I can fill in this area model by multiplying the two numbers. So 0.25 times 0.4 is 0.1. So this is 10% of the students walk and are male. Let's see, 0.75 times 0.4, this is 30%. 0.25 times 0.6, this is 15%. And 0.75 times 0.6 is the rest of them, 45%. If I add up all these percents, they should add up to 100, right? Okay, so now let's look at the questions. The probability that a student is female is just asking that number right there, right? If 25% are male, the rest of them are female. So the probability that a student is female is going to be 75%. All right, what is the probability that a student is male? Okay, so we're looking in the first column and does not walk to school. So that's going to be 15%. What is the probability that a student walks to school or does not walk to school? Okay, walks to school or does not walk to school. Well, without even having to look at our table, you tell me, what is that probability? That's going to be 100%, right? Either they walk to school or they don't. Okay. All right. Identify the sample space in part B and C as a union or intersection. Okay. Part B, a student is male and does not walk to school. That is an intersection, right? We're looking at the intersection of this column and this row that gave us 15%. So B is an intersection. And we can also tell because of this word here, and. And tells us that it's an intersection. In part C, we have an or. That tells us that this is a union, right? It is one or the other. We add the two together. 40 and 60 give us 100%.